Hello again. In this video, I will show you how to properly assess the relative cost of hot water in your facility. The cost added by heating is often overlooked. However, the cost to heat a given volume of water can be 4 to 7 times the cost of purchase. Therefore, calculating the relative cost of hot water can help realize savings that have previously been overlooked. There are a variety of ways that a facility can go about heating their water. This video will cover the necessary information and calculations related to the 3 most common methods. I will begin by discussing the most prevalent method, which is natural gas heating, then move into electric heaters, and finally touch on steam injection systems. Natural gas-driven heaters are the most common type of water heaters and can often be used in operations of all sizes. When these water heaters are used, the relative cost of hot water is equal to the cost to purchase water plus the cost of natural gas to heat that water. Some of the ensuing calculations will utilize the unit rate your facility is charged for natural gas. It is important to note that the true unit rate is not the same as the one you can see on your monthly bills. The true cost per natural gas unit is inclusive of taxes, fees, and all other charges. To calculate the true unit rate for your facility, the total cost for one billing period should be divided by the usage for that same period. We need to gather natural gas and water consumption information for the heater in question. This is most accurately done with meters, but it is also possible to find information on your particular heater in the specification sheets or operator's manual. When directly metered usage for natural gas is available, the relative cost of hot water is equal to the unit cost of water times the water usage plus the unit rate of natural gas times the natural gas usage. If directly metered usage is not available for the natural gas, it may be necessary to dive further into the equipment specifications and find information regarding the amount of natural gas needed per unit of water. For this case, the relative cost of hot water will be equal to the ratio specified in the manual times the unit rate for natural gas times water usage, all divided by the efficiency to account for incomplete combustion. Additionally, add the initial cost of water, which is just the unit rate multiplied by usage. Electric-driven heaters are less common and typically used for smaller processes and facilities, but still contribute a significant additional cost to water. When these heaters are in use, it is necessary to add the cost of electricity during the heating process to obtain the relative cost of hot water. The procedure for this calculation is fairly similar to that of natural gas. Begin by collecting water usage data, then consult the specification sheets to determine electric usage, demand, and efficiency of the heater. Next, determine the unit rate at which you are billed for electric usage and demand. It is important to account for both usage and demand charges in this analysis. Excluding one will leave some of the heating cost unaccounted for. For this case, the relative cost of hot water is equal to the usage ratio times the unit rate plus the demand ratio times the unit rate. Both of these are multiplied by the water usage, and the entire numerator is divided by heater efficiency. The last step is to add the initial cost of water, which is just the unit rate multiplied by usage. Be careful to use consistent units throughout. Steam injection heaters are slightly more complicated to account for than the previous 2 types of water heating systems because the cost of steam must first be calculated. The difficulty level of these calculations correlates to the complexity of your boiler system. The subsequent example will follow a boiler system that contains a heat economizer on the flue of the boiler and a deaerator that pre-treats the boiler feed water. This is a fairly standard setup and moderately complex. When analyzing a boiler system, you should follow the flow of water and analyze each piece of equipment in the order which water reaches it. For our diagram, the first thing that you can see is that the cold water enters the facility and is softened. The procedure to calculate this added cost has already been covered in the previous video. Next, water flows from the softener to the heat economizer. This economizer recovers heat from the boiler flue stack. Therefore, the gained thermal energy can be deemed free, and no additional cost needs to be added here. Water then flows to the deaerator, which uses steam to reduce dissolved gases in the water. Steam is not considered a free input. In fact, a considerable amount of energy is needed to produce steam. We will need to know the amount of steam the deaerator uses. If you do not know the amount of steam your deaerator uses, I recommend using the Steam System Modeler tool, or SSMT. The SSMT is a calculator developed by the Department of Energy to help determine different aspects of a boiler system when only some portions are initially known. For our example system, we will use the deaerator calculator to help determine the amount of steam used per hour. To use this calculator, you must know the deaerator operating pressure and venting rate, boiler feed water flow, inlet water pressure and temperature, and the inlet steam pressure and temperature. Inserting this information into the deaerator calculator will allow you to determine steam usage in 1,000 pounds per hour. Now that we know how much steam is used by the deaerator, we can follow the flow of water to the boiler and start our analysis here. To analyze the boiler, we must collect water and natural gas usage data. Knowing that 1 gallon of water equals 8.34 pounds, and assuming that 1 pound of water is converted exactly to 1 pound of steam, we can calculate the cost of steam produced by the boiler. The cost to generate 1 pound of steam in the boiler is equal to the cost of water for the analysis period, plus the cost of natural gas for the analysis period, both divided by the period water usage, keeping in mind that the cost per period is just the unit rate multiplied by usage. Now, using the previous answer, calculate the cost of steam used by the deaerator. This is done by multiplying the cost per pound of steam by the amount of steam used by the deaerator. To calculate the overall cost to generate steam, we must include the steam used by the deaerator. This can be done by adding the cost of water used by the boiler, the cost of natural gas used by the boiler, and the cost of steam used by the deaerator, and then dividing the sum of those values by water usage. Now that we have analyzed all prior components and obtained a cost per pound of steam, we can move on to the steam injection heating system itself. For this analysis, you will need to know the water and steam usage of the injection system. These parameters can often be found in the equipment specification sheets, but you may need to contact the manufacturer if they are not. To finally calculate the relative cost of hot water for the system we have analyzed, add the cost of water used by the steam injector plus the cost of steam used by the injector plus the cost of softening and divide by the water usage for that period. Thanks for listening. The next video in this series will address the cost added by wastewater surcharges and high BOD concentrations.